Third game looks a lot like that first game, putting things in one of two groups. Here it's the group of stations. Is it stations? Yeah, stations that stay open and those that don't stay open, those that have to get closed. So sad when stations have to close. N and R cannot both close. They can't both close. One of them at least has to stay open. The last rule is the mirror of that, right? R and L can't both stay open. One of them at least has to close, and so I'm showing that to myself visually. And then if N stays open, so does L. If R stays open, so does M. Let's answer some questions. Question 12. Which of the following could be a complete accurate list of the stations that stay open? Answer choice A, L, and M. We were just talking about this. The first rule is that you can't have both R and N closed. One of them has to be open. Answer choice A doesn't include either one of them. It's not complete. Answer choice B says P and R, but that's also not complete because if R is open, so is M. Get rid of B. Answer choice C says M and N and Q, but that's also not complete because if N is there, so is L. And answer choice D says M and Q and R, and that doesn't pose any problems, but contrast that with answer choice E, which tries to have both L and R open, and the last rule was that L and R cannot both be open. That's over-complete. It's not correct. 13, if exactly 5 of the stations stay open, which of the following must close? So we know that we have to close either R or L. But look what happens if we close L. If we close L, we also close N. And now we don't have 5 stations to be open. So if we're going to have 5 stations to be open, we'll have to close R and then leave open N, L, Q, P, and M. So if you're going to do 5 over here, you're going to leave R over there. 14, the stations that close could include both M and R. Can we have both M and R being closed? Well, I've got a rule. If M is out, so is R. And if R is out, N is in, and I'm just going to follow, right? N is in, then L is in. L is in, then R is out. And I don't know about P and Q, but that follows all my rules. It's totally possible that the closed stations include both M and R. 15, if L is open, any of the following could be true. If L is open, what can't be true? N closes. Why? I don't know. Let's see. What do we know when L is open? R is closed. And if R is closed, N is open. Oh, that's why. If L is open, turns out N has to be open. Answer choice B is false, and that's why it's our answer. Question 16, if exactly 2 of the stations stay open, who has to close? Well, if you've got 2 stations open, it's kind of like what we were doing with the last rule in this earlier question, but now we're doing it in the other direction. 2 stations are open. Well, the stations that are open always include either R or N. So our open stations are R and somebody or N and somebody. If it is R, she brings along M. If it is N, he brings along L. So our 2 stations that are open are either M and R or L and N. And who has to be closed? Not L. L could be open. Not M. M could be open. Not N. Not R. Those are the 4 that could be open. Who has to be closed then? Whoever's left. And that's Q and P. And we just didn't get P as an answer choice. All right, that leaves us with only 17, the substitution question. The thing with the substitution question is that it means that the right answer is going to be exactly the same as the old rule that it's substituting for. And this is the rule we're substituting for. And what that means is that every time this rule is true, answer choice A, the correct answer, is also true. And every time this rule is false, answer choice A, the correct answer, is also false. That's what it means to be a substitute. It means that they are the same. And here's how it works. If I make this rule true, R brings M, and what else do we know? R kicks L out, and L kicks N out. Then answer choice A, if L closes, M is open. If M closes, L is open, is true, right? I made this rule true, and that just made answer choice A true. And the flip side of that is, if I were to make this rule false, and the only way to make it false is to say, well, I've got R and I don't have M. So I've got R and I don't have M, and now I follow all my other rules, right? R means no L. No L means no N. Now I've made rule 3 false. And look, I've also made answer choice A false. A said if L was out, M was in. But if this is false, M is out, and L is also out. And the fact that every time rule 3 is true, answer choice A is true. And every time rule 3 is false, answer choice A is false. That is what tells us that A is the same as rule 3. It is our substitute. It is the right answer. For any of those other answer choices, you can either make this true and make answer choice B false, or you can make this false and make answer choice B true. They don't have to be the same. B, C, D, E are not exactly the same. They're not substitutes. They're not the right answer. Only A is both true every time this is true and false every time this is false. And that finishes this game.